Hi there. My name is Michael Becker, and I'm the Personal Data and Identity Working Group Chair for the Mobile Ecosystem Forum. And I'm really happy to be the host today of an exciting conversation, IoT Enhanced Services Value Chain Explained. And what we're going to be looking at through the lens of 6 leaders within the industry, the idea of how connectivity, hardware, software, security, testing, and more all come together within an ecosystem for IoT deployments. So without further ado, I would like to hand it off to our first speaker of the day, Jimmy Jones at Zariat, who is the sponsor of today's webinar and has helped us pull together this broad ecosystem. And so with that in mind, Jimmy, you've got the floor. And let me give you control here now too. There you go.
Okay, well, first of all, thank you, Michael. And we're very pleased to be able to speak with you today. So for those that don't know, Zariat is a cellular IoT connectivity provider that was initially formed with the idea of providing the most secure cellular access possible for IoT. And we went about achieving that by building the most secure network possible, which we could do because of our engineering heritage and our company and its staff. And that's worked really well for us. We've got a very secure network, which is a fantastic base to build from. And it's won us recognition and awards such as the GSMA GLOMO Award at Mobile World Congress. But we felt that we needed to give more tangible benefits in security and innovation. So we decided to ask ourselves a question. And that question was, if technology was no object, what would your technology was no object, what would your connectivity do for you? And now that's a question that all our sales team ask all our customers. And we're confident of asking that question because we believe that all IoT solutions have the same DNA. They're made up of the same 3 elements: the device, the network, and the application. Now, you can get any device made and any application built, but that part right in the middle, which is the only part that touches both sides, is often really opaque and you can't see what's in there and you can't control what's going on. And that's what we're looking to change. We want to open that up so you can join the dots and create more cohesive IoT solutions. And we're lucky as we can do that because of our in-house skills. We own our own network. We have access to the SIM as well, which is very unusual. However, the issue is that those 3 elements, why does it go backwards when I press that? Okay. Those 3 elements, while they may be the basis of every IoT solution, their IoT is hugely diverse. So it means the answers we get are very diverse as well. And that's what...
And Jimmy, let me stop you right there. Let's just put quantified. We're talking billions of devices in tens of thousands, if not millions of types of devices when you say diverse. Is that correct?
And solutions. So the actual size of the solution doesn't really matter. It's the diversity of the solutions, from your smart car to your smart light to your smart dog bowl. That's where the problems come, because in telecoms, usually there's just 3 solutions. You ring your wife, you text your mum, or you surf the internet on your phone. That's not telecoms anymore. Telecoms is having to deliver against everything. And that's where we need to look at being able to partner with people with with more diverse skill sets. And that's exactly what brought us to the idea of working with a partnership. And we created an ecosystem of partners, and that's allowed us to expand what we can give as an integral part of the connectivity. And that's already bared fruit. And as you can see from the slide, my final slide, that feature offering today is really rich, and that's delivered only because of the partnerships of the people who are on this call.
And Jimmy, before we jump into them, can you give us a high level of this? And so the key concepts we're talking about is identity management, security management, software development, testing, certification, regulatory compliance. Is that what you mean? All of the above?
All of the above and more. So every solution, there is a massive difference in the way telecoms people speak and the way IT engineers speak, but they're speaking the same. They're not speaking the same language, but they're talking about the same things. So if we can start to take that information and instead of saying, we don't do this, we do that as a telecoms company, say, what do you want to do? How do you want to do it? Then if they want simplified security, if they want end-to-end encryption, if they want simplified management, all of these is going to be spoke about in a moment, much better than I can explain them. We can actually do that. But more importantly, we can work from what the goal is. If somebody tells me, okay, I want to achieve this, it might be called something in one particular vertical of IT. It might be called something completely different in telecoms, but the option is there to do it. That's what we need to do. We need to start removing that veil of that fog and start opening up that centerpiece, which is, as I said, the only piece that touches both sides, and create a cohesive solution that actually addresses what the device is trying to do, not what we can just try and sell.
Sorry. So with that in mind, and since we have limited time and so many speakers today, let's hand off that first piece over to Chris. And Chris, can you talk to us about like what is @Sign's role within this broader ecosystem? And
yeah, sure thing. So
take control, I'll go ahead and do that.
Yeah, thanks, Michael. So hi, I'm Chris Swan. I'm an engineer at @Sign. Our founders had this mission to allow people, entities, and things to connect in a simple way, but that provided security and privacy. And for the past 4 years or so, we've been building the protocol and then the platform that implements the protocol in order to provide very simple identifiers, a simple text-based identifier for all of those elements, whether that's a person, an entity, or a thing, and then to connect together those people, entities, and things in a secure end-to-end way. So if I go to the next slide, this kind of shows an illustration of the basic connectivity. So a client can look up an address in the @directory and make a connection to it. And if you can just advance this, Michael, to the end, then what we're providing here is an app that's built on top of our platform that facilitates secure remote admin, because this is one of the needs that just about everybody in the IoT space is frustrated by, that devices get out there into the field and the networks that they're on and providing access through the networks that they're on makes it often very difficult to do secure remote admin. So what we're doing here is making use of this platform that we've built and the identities within it to use that as a control plane. And with that control plane, get the devices that are deployed into the field to connect securely back through a rendezvous point to the client devices that are administering them. And once that's established, we can have an SSH tunnel from end to end, but that's achieved without having to have any ports open on the device, which means that we can traverse many layers of NAT if that's necessary. We don't need to know the IP addresses that we're connecting to, which means the devices can move between networks. We don't even care whether it's IPv4 or IPv6. And so this is a very flexible, but also very secure way of getting connectivity. And with that SSH tunnel in hand, we can use that for straightforward console-based admin, but we can also tunnel other connections over that. So whether that's a web interface or RDP for a Windows environment, whatever the choice of protocol, that can be facilitated.
So Chris, before we move on though, I mean, you threw out a ton of technical jargon here, and quite a few people may not be familiar with a lot of it. But what I heard you say is @Sign as part of the Xeriot ecosystem isn't making it possible for every person, entity, aka organization or thing, a device, to have its own unique ID, and that the connection between devices and across networks is end-to-end encrypted. The owners of those IDs, the owners of the people, the entities have control over the flows of those communication. And then the privacy perspective, I think, is really clear, because as we as industry define the term privacy, I think we need to go all the way back to the way Alan Weston defined it and started to define it in 1964, where he said it's really about control. It's the ability for people to choose the who, what, when, where, for what purpose, and for how long someone has access to me. So when you're talking about privacy, you're saying the network connections between these dividing end-to-end endpoints are completely secure, and the controller of that experience, that solution, gets to choose the who, what, when, where, and for what purpose any of this data might be accessible to any of the actors within that communication experience. Would that be a correct way of saying it?
You've absolutely nailed it all there, Michael. And the only thing I would add is that as part of our partnership with Zarya, we've been exploiting their expertise around SIM cards in order to put the private keys for these identifiers into the SIM card. And that reduces the overall bill of materials for the devices, because there's no need to add another trusted platform module in order to do that.
And that's what's really critical. So that with these two pieces, we have Zarya providing us the overall network based on their SIM card technology, plus the networks they deployed. And then you, based on all those SIM networks, make that connection completely secure and give control to the actors, on all ends of the experience.
Yeah, absolutely.
And there's one more step from that, Michael. That's not solely on cellular. That umbrella can go across cellular, wired, Wi-Fi. So it's a brilliant story for Zarya, because the app enables the full digital transformation from a wired network to a wireless network.
Right, and so independent of even the once it's in an IoT device, you don't really care what the connection protocols are, which you were talking about earlier, Chris. It just works, and that's part of the automagical secret sauce that comes in this process.
Yeah.
Okay. So with that in mind, Chris, any more to add, or can we move on to our next contributor?
Please keep going.
All right, so let's pop over to Roger. And Roger, so where do you now fit? We've heard about connectivity, and we've now heard about end-to-end security and privacy control. What's Able Device contributing to this ecosystem?
So, I mean, it's actually great to be here. And when I say this, I don't mean just this webinar. I mean part of this ecosystem, because Able Device is enabling technology that's embedded in part of a solution of somebody else's solution. I think I don't have control of the screen, Michael, if you could.
Oh yeah, let me give that to you real quick. And while I'm giving you control, Roger, maybe you can introduce yourself real quick.
Oh, sorry. Yeah, I'm Roger Dewey. I'm the CEO of Able Device. Where we're located in Raleigh, North Carolina, and our technology is all SIM-based technology, and that's what we're going to show you in a little bit. But we're
and real quick, before we move on, is SIM always that little piece of plastic, or are you also working on eSIMs as well, the virtual SIMs devices? Any
form factor at all. So iSIM, eSIM, little pieces of plastic, and that's the great thing about SIMs, is that it's a global standard, and the standards are forwards and backwards compatible. So we work on any SIM from any generation and any form factor going forward. Let's see if we can get it to progress.
If not, I'll just take control for you.
Okay. So again, this is what I was getting about here. You have enterprise challenges, and we've been working in the IoT space for a long time, and now we're starting to move more and more towards enterprise mobility. And when I say that, we've been dragged into things like private networks, switching from a public network to a private network, some things that should seem to be easily done, but really aren't. And when we look at the challenges we've had in IoT is really enterprise connectivity, if you think about it, right? Other than consumer wearable things like that. And what's been holding back the success of everything, and it will cause problems in private networks unless it's solved here also, is a lack of an ecosystem. I'm sorry.
And can you define for us private network versus public network? Private being one owned by an enterprise, public being carriers. I mean,
so enterprises can now start their own 4G, 5G private networks.
Okay.
They can either, it's their own slice of a network. They have their own antennas inside the building, and they have control over the connectivity and what's connected to that network at that point. They're using either in-house spectrum CBRS, or they're using it from an operator and also using an operator's roaming portfolio. So you have this promise of this technology, IoT or private network, but there's a lack of tools for the enterprises to deploy these things the way they want. The ecosystem for mobility has always been based on mobile network operators and these giants, things that only work at scale. All 10 million users get the same thing. All 100 million users get the same thing. No real flexibility down there. And enterprises aren't used to working in that, and they don't like working in that model. And that's been part of the resistance to mobile IoT and I think mobile enterprise private networks also. Okay, let's see if we can get to the next one.
Mm-hmm.
There we go.
Too far. Okay.
Okay. So now it was in buffer, I guess. So
yes,
there we go. So what we have is SIM Bay, and SIM Bay is an applet that resides on a SIM, sits on any SIM from any manufacturer, any operator. In this case, you can pre-deploy SIM Bay on every SIM. Let's say Zariat SIM that you want, you can ship it. It doesn't do anything until you configure it, right? And when you configure it, and it's configurable by the enterprise itself, it doesn't have to be down at the operator level. You can tell it the way you want it set up for your deployments, and maybe you'll have one configuration for your pumps and another one for your trucks or something like that. So it really fits more in an enterprise model. You ship it on every SIM, and it's like Excel on a laptop. It's just sitting there until you activate it, and then when you activate it, you configure it to work the way you want it to work. We have built-in scripts for common functionality. There's safety and security because it's on a SIM. It's virtually unhackable. And basically, it acts as a state machine, and it has these micro features in it, probably 20 different micro features that give you the ability to mix and match different functionalities. Again, think Excel, the way you would configure an Excel sheet and what the formulas will allow you to do. And to this point, the features we have, we can string together for different functionality and different use cases. And our biggest one right now is quality of service. And we have customers out there who are doing steering based on roaming signal strength. So signal strength is too weak to get the functionality, let's say paying a credit card swipe or something like that. It'll start to look for another network with stronger signal strength based on the rules you as the enterprise configure in there. We also have app and device security. We have IoT safe being deployed right now. We have a major OEM in automotive space that we do the key store for on a standard eSIM. And they came to us, it was already in the device for connectivity purposes. We put the key stores on there, and they have an API, and it's for maintenance purposes. It's not even for the connectivity in the wireless network. It's for when you plug in the maintenance port. Mobile network efficiency, things like signaling storms and congestion. We can put the back off timers on the SIM, so that way you don't have to worry about was it created or programmed correctly in the device at the time the device was manufactured. Gives you the ability in the future to change things and manipulate the machine's behavior just by changing some of the values that are on the SIM at that point. We can also do remote diagnostics and testing. We can do debugging, give you the ability to use the SIM as a side channel to access the device and start to look at the communication stack and what might be going on in the device at that point. So I think I'm getting close. And what this gives the enterprise at that point, it gives you operational efficiency as we have in here, gives you the ability to make things work really the way you need them to work, not good enough because that's what the operator is offering at that point. Again, built-in security. SIMs are secure elements by nature. They're designed that way. It's the same chip that's on your bank card going forward, and that's the reason it's used. It's the exact same technology put out by the global platform running on a Java card. This reduces costs because we're leveraging an element that's already there, the SIM. You've already got that sunk cost, and on top of that, it's very flexible and future-proof as you move forward. So as you move through different generations of SIMs, also doesn't require any special nodes in the network. and it doesn't really require any special platforms or services. We can do all the intelligence and all the work on the SIM, and that improves, as I said, the customer experience, and it allows you to deploy it very rapidly at a very low cost, and then change it at any time in the device's lifecycle. You can always update that script. Very small. It's a very small package the size of one SMS to manipulate a script and put a whole new script in a device to make it act completely differently. So that's kind of the quick overview that I could figure I could fit in 6 minutes. How did I do there, Michael? Looks like I'm
and move on to and talk about this. Yeah, when we talk before we move on, when we talk about this, then it's interesting that you're enabling an enterprise now to essentially to empower its devices and its network, and those devices can become representative agents of the network, if you will, and participate within its value chain. And you can basically automatically update it, modify it, change it, refine it, and do so securely based on and presumably you work independent of, say, like @Sign. So you're just a member within the ecosystem, but collectively we can all work together.
Exactly. That's why I said we need that ecosystem, because we are very narrowly focused. We're not platform builders or security experts. We're SIM applet guys. We need to work as part of an ecosystem. And again, that's why we're really happy to be involved with the Zariat and just going forward in this ecosystem. It's what's been, and then
presumably you've got the professional services too to help an enterprise figure out, like, how do I tell my device to do what it needs to do? Because using your Excel analogy is great, but at the same time you need some education on how do we build these formulas, how do we build out this logic.
Yeah, then we do that, but what we're developing right now is a drag and drop node editor. So it's going to have all the functionality in there. So you just drag the functionality you want and connect the line, since it's a if this then that kind of state machine. That really empowers. You don't need to know how to program. You can be an administrator level in an IT department and figure out how to put this together and modify.
And we don't for this today, but I would love, and maybe Jimmy, this is a follow-on webinar we could do. What happens when we add AI decision making support into the dynamic controlling and retrofitting of these types of experiences? But let's hold that one for later, for maybe Q&A at the end. So let's move on now, and please tell us, Amit, what's going on with Smart Axiom, and how do you contribute into this ecosystem?
Hey guys, this is Amit Biani. I'm from California, and we build Smart Axiom build a decentralized and distributed ledger system to securing the IoT system and managing across the network. So we're focusing on how to develop the defining the identity of the devices and how we're going to be dynamically secure over the edge network and over the cloud. So we deployed our we had a basically we need to understand why the blockchain is basically more important to use under IoT security. That's a very important part of that. Can you move?
Yeah, you have control now.
Yeah. So IoT security are if you look at the IoT system built our very different protocols and very different system, and a lot of sensors and devices are very resource concerned. They cannot run they cannot always connect it to the network. They come on and off on the network, and they have a low, a lot of built on the battery operated system. So how do you going to secure those things, and how you're going to build their identity, and how you're going to validate those networks? And if you can rely on the cloud services, or you rely on the and any other central services, that will be creating a lot of issues on the network. Those devices are very resource concerned. So what we come up with the very decentralized system and distributed network across the edge network and between the sensor layer. So that we generate the identity and we validate the identity on the network. So that's.
If we went too far, whoops. There you go.
So in our system, what we did, like we split into like a 3 layers. One is a sensor layer where we're defining the all the sensor identity, and we build a beachhead library, and those libraries goes into the system that generating the identity, and those identity will define on the chain on a blockchain network, and on this and on the blockchain network we validated those identity, and then after we had an encryption mechanism built inside the beachhead library that dynamically generate the signature, secure the data when they are moving from the sensor. We encrypted on the beachhead library, and we transported onto the on the OT layers where the all these block lock layers are running. So block lock layer is basically built on the zero trust architecture. So we generally don't trust any sensor data or any identity comes over the network. We validated the identity, and then after we validated a transaction, and then we'll take into the so we build like a 2 multi-chain architecture in our system. So one is a data plan and control plan. The data plan is basically storing the identity, generating the identity that will help to provisioning the devices over the network much easier way. And the control plan where we are generating you define the rules and you define the all the permissions, like how the system will build. So we used AI services on the cloud that generate the contracts. Those contracts dynamically run on the edge in our blockchain fabric, that is a block lock, and that block lock execute on the system, and then it will validate every identity that's moving across the network.
Okay, and can you help us? So let's say give us a context here a little bit. What is the IoT device in mind? Like, walk us through an example.
Like any kind of a devices that you can use is like we're using a sensors, actuators, and we are like we build.
Let's say, for example, my smart meter on my home that's measuring my electricity output. Would that be an example?
Yes, smart meters, and if you can have your smartphone, a smart cameras, and any sensor.
So I've got a smart meter at my house, and that's sensing power and water consumption in my house, for instance.
Yeah, so we generally we put we generate the identity of the smart meters over the network, and that is a token. So what we did, we collect all the physical informations of the devices and generate the one token. That token is validated across the network and our distributed ledger system. So like if anybody comes accessing those, they can just use the token to access the information of your smart network. They never look at the physical information of your devices. They just look into the tokens, and the token will pull all the informations. All the transactions happen during across the whenever the device online or whether the device are working, and that will giving all the informations of the devices, like on your smart meters, like how many times it will sensing the power numbers, what's the conditions, and what are the power numbers are during certain time period that you're using. That will be pulled by the system much easier way.
Okay.
And then what we did, like I work with we work with the Chariot to understanding, like we are working with a lot of healthcare pharmaceutical company, and we working with the Honeywell, and then we had some other projects going on automobile, where like we came across with the Chariot, and we try to understand like how we're going to build our system to more secure on connectivity, and how basically we don't want to depending on the lot of device manufacturer to integrate our beachhead library. So what we did, like we come up with we build the applets that runs on the SIM, working with the Chariot to build the applets that run on the same application area, where we can secure the identity. We store our cryptographic keys on the system. And then we will whenever this beachhead library accessing those tokens, those are securely accessed by the beachhead library, and that will register on our blockchain network, and that we validated across the network. So that what the Chariot is providing us to how we attest the keys on the system, And then how we going to translate those identity over the network, and then how we tokens that we are registering in the SIM that must be easily identified over the networks. Like we can go any kind of a devices, like we deployed a lot of tracker devices, we deployed a lot of sensor devices across the network on automobiles. And what we're doing, like we're taking a lot of Bluetooth devices over the network through the blockchain and Chariot system and register on our blockchain system, and we validated across the network their temperature and giving a real-time traceability and audibility of the system on this network.
And can I infer then part of the value of this overall methodology or means of deployment is, when someone deploys a device into this network, you can be assured that that device is allowed to be there. So, so it would be very difficult for someone to try to deploy a device and not have it properly registered into the blockchain. And so that anyone then can validate that this device is allowed to be in the network, or anyone can validate that this entity that's trying to gain access to this device or control this device has the authority to do so because they're part of the cryptographic contracts and part of the data exchange. So it's a methodology to enable distributive security and access and delegated authority, both for devices, people, and the enterprises participating within this ecosystem. Would that be a nice way of summarizing it?
Yes, that's the right start. It's absolutely nailed that. So the best of the way we did that, like we connected the sensor layer, OT layer, and operating layer into the one single ecosystem where we can combine it. So that Chariot help us to combining our cellular network and connectivity to our OT layers that we are building on a block-like layer. That was our very important parts that Chariot will solve some of the challenges that we had when we are deploying in Honeywell projects for one of the pharmaceutical company, where we are transporting the real-time sensor data for when they are shipping COVID vaccines or a lot of vaccines. Those are validated through we use the SIMs and then applets to validate those conditional access that they require and execute dynamically on those.
Yeah, and on that point, for example, in the COVID vaccine distribution, this is mission critical stuff. And if you have temperature variances in any given particular degree, you can end up destroying the entire batch.
Yes.
So the fact that this is being done in real time is immutable, i.e., cannot be changed or frauded, if you will. It gives both the receiving party of those vaccines as well as the pharmaceutical shipper great sense of security and peace of mind that the product is safe and secure throughout the entire process.
Yeah, that's absolutely right. And what we did, like one of the things that if you can look at in our value props, what we did in our system, we can have a traceability and transparency, and we compliance all the regulations that required by pharmaceutical company, HIPAA compliances, and they have any security kind of privacy compliances we can put together in our blockchain layer. And then we have audibility and anonymity. So they can audit every transactions and every device identity, who is communicating and what are the informations they are sending. They can track on this, and then whatever that you told us, like we can easily identify the frauds. If somebody, like one of the sample that we are discussing with Honeywell said, hey, we had COVID vaccines are shipping, and a lot of COVID vaccines can't be still, or they can ship it into the small boxes. They will be stolen by the lot of internet during the shipping from distributed network to the on the medical centers. How are you going to secure it? So that's what we build. They can use our technology to identify every fraud happening during the shipping or maybe during the transactional process. And what we did, like we did have real-time analytics, like all the data that we collected, we put into our Tenacious services. Tenacious services, what we do, we identify all the anomalies on the networks, who is connecting, what are the informations they are sending. And based on that, we generate the rules. Those rules we are imposed on our blockchain fabric, and they dynamically validated all the rules whenever the data are coming into the network.
Fantastic. Okay, and I think this is a nice point to raise that too, is as Jimmy pointed out in the very beginning, often for the layman, when we think IoT, we think our watch, our smartphone, our car, or our thermostat, maybe a smart meter. But what you're pointing out is, especially in like shipping and supply chain management, or trucking or whatever that may be, there are literally, trillions of these sensors floating around in the world right now. And with based on the ecosystem that we're discussing, we have the opportunity to manage and control those now, which we didn't have before, which I think is very, very powerful. And there was a statistic I read a while back that said by 2025, just to help people understand the scale of these sensors that are going out into the world, by 2025, we as every human being walking around will be interacting with an IoT device either directly or passively 4,800 times a day, both in work or out on the street. So you're going to, about every 18 seconds, your phygital self will be pinging some type of IoT device 4,800 times a day. And so that's why it's so important that these connectivity layers and these operational layers are there, and they're secure, and the privacy and the control and the identity management is getting so well locked down. And so with that in mind, let's move on to our next contributor to the ecosystem. And so Robert, what do you have for us? And please introduce yourself and share your contribution to the ecosystem.
Thank you very much, Michael. My name is Robert Wakeling. I'm the CEO and founder of a company called Udara. When we partner with Zariat. We've known some of the guys there for a very, very long time. So whether the device is static or it's mobile, we can track where it goes and how well the network it kind of camps on is working. And if you think about the whole thing in terms of IoT from end to end, if you've got an IoT application, there's going to be at one end some application of some kind which is doing something, and at the other end you've got a management function that's got to make sure that that application is functioning perfectly and at scale. So part of what we did was to write some software that measures the quality of the networks that we connect to, but also through mathematics and radio measurement, we can geolocate devices, latitude, longitude, position them without using GPS, and we can do that globally. So there's scope for kind of approximate accuracy tracking using our solution. There's also scope. Well, that's mainly the one of the applications that we're getting into, but the rest of it is about how well that device can remain connected to service. So
I got to pause you there. How are you doing that? How are you geolocating without GPS? Is it like Earth magnetic, or what's the strategy there?
So we sample radio measurements almost constantly, and those radio measurements are triangulated to locate the device. There's some other kind of algorithms in the solution to get rid of problems like path loss and interference, but fundamentally it's an approximation of the device location based on its radio context.
And from a management perspective, it's close enough. It's like horseshoes and hand grenades. You just need to get close enough to win the game.
Yeah. So it's rather than just say I've got a device and it's somewhere in France, you can say not just which region of France. You can say, well, it's pretty close to Lyon, for example, or it's at a particular street location in Lyon, because the cell density around that device makes the solution more accurate. So you can have an approximate location heading toward the metropolitan area, and then a refined location when they actually get to somewhere where there's a lot of cell towers, so 5G in particular.
Hey, so Michael, we used Udara's services. We tested out, and one of the use cases that we have how we can optimize the batteries. And that was one of the way we can use their services to switch off the GPS signals all out completely, and we use their services to track our assets and our shipments to using their technology. And we successfully tested out in one of the semiconductor assets management system to securing.
And thank you for jumping in. That's a great example of the power of the ecosystem. So any one of you independently couldn't do this alone, especially without Zariat's network and chips. But in that regard, every one of these IoT devices has to have some kind of battery or power on it. And if you can limit or reduce the strain on that battery, you're going to extend the life of the IoT device. And so that's one use case I just heard you say is the water solution could help extend the life of an IoT device that's out there in the field, used in that context.
Yeah, and it could also make a device which would an e-mobile device. What I mean by that, there is no location capability. You can have a much cheaper bill of materials for very, very simple electronics, and you can track it. Whereas the traditional solution is a very large battery with a GPS receiver. So if you want, you can, using GPS to track large but high value containers is probably appropriate, or a car because it has a large battery. But if you're talking about much, much lower cost of goods and you're still transporting it around the geography and it's part of that workflow, it is conceivable that you can have very, very cheap locating capability on lower cost goods.
Fantastic.
Yeah. So I'll give you some examples if you could just scoot to the next slide. Okay, so the endpoint device, whether it's a retail consumer mobile phone, but in this case, an IoT device, we talk about the user journey. And this still applies to IoT devices. We have basically got a line-by-line record of what's happening to that subscription. So we know when it switches itself on, we know how long it takes to connect to service, we know its mobility through the network cell topology, and we know its location by latitude and longitude. So you can identify which network is being used, what part of that network is being used, and where in real terms that device is. And we give you a measure of the quality of that connection, so we can tell you signal strengths and interference. Mm-hmm. Next slide, please. So this is an example of some subscriptions from a North American carrier roaming in Canada. So we don't have cell plan data for the Canadian networks, but we can use open sources plus the record that we've got ourselves. So these are just devices which have gone over the border. The coloring indicates the network type that's being used. And as you can see, I mean, Canada is a fairly sparsely populated country, and there's a lot of congregation on the left and the right, not so much in the middle. So we achieve this globally. So it's, next slide, please. Okay, so this is where we've drilled into it a little bit. So you can see the legend on the top right-hand corner gives an indication of the kind of detail that we provide. So that might not actually be too useful to people who are working at a higher level and they're worried about some tracking application or sensors in electricity meters. But I'm just demonstrating there that we've got a lot of detail about the connectivity and the quality of the connection for that device. And IoT is great. We talk about it as the Internet of Things, but these devices have to be connected. And if they're not connected, we can at least indicate whether it's a cellular problem. If it's not a cellular problem, then it's something else, perhaps the application in the device or the application at the back end that's supporting that device.
All right. And I'm hearing, are there consumer applications to this? Or I'm hearing, so far thus far, I've heard a lot of enterprise related IoT experiences from many of you. And perhaps there's pure enterprise, there's pure consumer, and then there's like the hybrid where the chip's in my car and it's kind of maybe a possible mix between the two. Can you talk to me a little bit about that? Where are you seeing this mapping of experience?
So I can give you some specific examples. So one would be a car manufacturer that we're working with. They have the eSIM implemented in their cars, and they are deploying our product in the route profile, so the ISDR, so that when that vehicle goes to a particular country and it's personalized to the individual buying it, there will be a local carrier profile put in this eSIM for that car. Because we've implemented our product in the route, then we can measure the performance of that carrier. So the same vehicle could go to different countries. We just have one bill of materials for our customers' benefit in the route. Other applications include, we've got telecoms regulators that are part of a government that's trying to improve the economy of a particular country. And the part of it is to improve tourism, health, communication. Communication means roads, planes, trains, and automobiles, but it also means mobile telephony and fixed line telephony, not so much fixed line because mobile telephony can probably usurp that. So in this case, the regulators adopted the solution and they apply it to their carriers and countries so that they can get a measure of the performance of those networks to make sure that they are adhering to their spectrum licenses and ensuring that they give good quality to the citizens of that country.
The other thing, Michael, is I think the enterprise, when we talk about it, is the solution owner as well. So all of these, everything we're talking about today could be applied in multiple different verticals, and that could be consumer, that could be medical, it could be vehicles like Robert was talking about. So actually everybody on this ecosystem is an enabler to both commercial and personal solutions.
Mm.
Yeah, and it's supply chain, and it's all of these different aspects. And again, I think the kind of golden thread that I'm hearing going throughout all this is, as you talked about in the terms of the DNA, is the device, the network, and the applications that run across it. And what we've been talking about thus far too is how do we secure all of that? How do we ensure privacy across all of that? How do we make sure that we can effectively manage and maintain software on the applications and policies updated? How can we track where these devices are going? All very exciting stuff. Let's now move on to Andre. So Andre, what's your contribution to this ecosystem?
Yes, hello.
Brief bio and give your contribution.
Yes, thanks, Michael. Thanks, Zarud, for the invitation. My name is Andre Kostin. I am assistant professor at University of Jyväskylä, which has a very nice cybersecurity spin-off called Binary.io, which I'm CEO and co-founder of. And I'm happy to be representing it as part of the Zarud ecosystem. What we do at Binary shortly, before I dig into the problem, is we develop an IoT cybersecurity platform with a particular focus on firmware analysis, binary reverse engineering, discovering vulnerabilities and other cybersecurity issues within the binary code, SBOM recovery, and moving towards automated certification. I'll explain a lot of this technical jargon in the next couple of paragraphs, but I'll be telling you about. So I really like the slide that Jimmy put together about the DNA, the device, network, and application. And I also like the thing that he mentioned, that the network is quite opaque to many of its end users, whether organization or not. And I would actually support the statement also for devices and applications. Even though devices and applications, you download something or you buy something from the store, it just looks nice, shiny outside, but you don't know what's inside as well. So they are quite opaque for the end user, whether organizational or end users. So it is very important to know whether they are secure, are they tampered with, do they provide a sufficient level of security or privacy that the end user is, for example, expecting from them for the given price tag, and so on and so forth. Now, the idea is that these devices come with a lot of hardware and software inside them. Many times the end users, organizational or consumers, don't know what's exactly inside. And I can tell you that even the vendors or system integrators producing them do not know exactly what's inside for multiple reasons. Because they run, for example, firmware and binary code, which is a little bit different than the thing that is the source code. The source code analysis can be done pretty nicely with AI tools or even more classical type of source code analysis. But in the end, the products, the devices, the networks, if you will, run binary code most of the time, most of the time. So binary code is something that needs to be looked with higher scrutiny than the source code, because it's the one running inside the device. It can also have a lot of hidden features, let's say backdoor or hard-coded accounts or other hidden code that is not visible in the original source code. And there are many reasons for that. Whether the build servers have been compromised, a very malicious engineer inside the company implanted some nefarious code, or just companies rely on a lot of consulting and third parties that just provide them binary blobs to integrate in their chips and their devices. So there are a lot of reasons, or at least a handful of reasons, why the binary code is quite complex and requires more scrutiny. So this is what we actually do at Binary. We focus on binary code analysis and reverse engineering for the purpose of cybersecurity. And many people ask how we do this and why we do this. Well, I like the analogy with human genome code decoding. meaning that there's a big chunk of code, which is quite binary or in some kind of encoding system. And you have to look for many different combinations to understand what exactly that code is doing, and whether, let's say, in human code analysis, you want to know whether two particular genes provoke a particular weakness or disease in certain subset of humans. Pretty much the same we do with a binary code for IoT, firmware, and any other system. We look whether particular sequences of bytes or patterns exhibit particular types of vulnerabilities or security issues that basically expose the device or the network where the devices are connected to various types of attacks. So for this, what we do, we do binary reverse engineering and recover very critical, important part of the information about the code without having access to the source code, which is very important from intellectual property rights of the original vendors and the other participants in the ecosystem. We also do this for reasons such as SBOM or HBOM, which are basically software and hardware bill of material. Bill of material is basically an ingredients list for the software and for the device. And it's very important to know what goes inside the software and the hardware of those devices, pretty much as you'd read an ingredients and nutritional table on a food packaging. You want to know what goes inside your body. Similarly, you want to know what goes to your network, whether it's home network, enterprise network, or any other type of ecosystem. And then we use this software bill of materials for other reasons, monitoring whether some of the components or materials in that bill become outdated, or maybe they are discovered to be insecure or unhealthy from cybersecurity perspective in the future. We also use them for automating what we call pre-certification. As such, certification is a much complex process, and it involves a lot of steps and also human interaction. Therefore, it cannot be 100%, let's say, automated. But certain automation is needed and is welcome, because we will have billions of devices that are quite heterogeneous, and there are not just enough experts to do this manually, as it was done before for, let's say, early SIM cards and similar types of devices that required high level of assurance. Now, with so many other smaller devices and cheaper devices, certification is required because of, let's say, ETSI 303645 or IOXT Alliance or UL 2900 and similar types of certifications. So automation is definitely required. And tools such as Binaris tools or similar tools can be used to provide a significant advance for the labs or the certification companies that want to move faster in the market and cover more verticals and more space. And I think this also provides kind of a good introduction to the next speaker about certification. But I would like to end the thing that probably Binary probably develops one of the best solutions in this space, with a particular focus on IoT. And we are happy to be part of Zariat ecosystem exactly for this reason, because it plugs into the DNA, the device, network, and application. The firmware updates go for the network, they go for the devices, and we are at the right spot to be able to analyze those firmware updates when they go to millions of sensors or millions of devices and SIM cards and whatever not.
So and so I understand what I heard you say too is it seems to be you're independent of the manufacturer, so you can do this type of certification with or without the manufacturer. And so if a third party wanted to, an enterprise wanted to say, look, before I bring this stuff into my network, I want you guys to check it out for me, you can do that independent of the person that actually developed the device.
Exactly. We can do this and help whatever interested party interested in certifying or verifying assurance levels. We can do this without the collaboration or willingness of a third party or of the original vendor. Of course, working with vendors is even more important or more fruitful, because they also know the ins and outs of the firmware of the device and so on. But because we do binary reverse engineering, is basically it doesn't require, let's say, proactive engagement of a vendor.
Perfect. And we have about a few more minutes. So let's let Pablo take us on and kind of bring it home for us. So Pablo, where does 7Shift fit into this ecosystem? Yeah, Pablo, you're on mute.
The most heard slogan the last couple of years. All right, so yeah, thank you for the introduction. So I'm Pablo Enves. I'm the CEO from 7Shift, and yeah, like I said, we're a security consulting firm that's been focused on IoT from day one, right? So we basically count IoT from anything that's between the chip and the cloud, which basically counts what we've been talking about, this DNA, right? And we try to support customers in performing in having secure solutions that cover that entire ecosystem, right? So what we do is actually we help with testing and pen testing, right? We also use tools like Binare.
Can you define pen testing for people that may not know what that means?
Normally what we call about pen testing, it's short for penetration testing. So we take a device or a system and we try to, let's say, hack it, all right, or perform security tests on it to find vulnerabilities or problems with security problems in it. And depending on how it's done, these can be, you know, with more or less collaboration on hands from the people that do it. So here's where we come into terms like white box and black box testing, right? Mostly white box testing are the most efficient for the client. You get the more bang for your buck because then the tester doesn't have to reverse engineer the entire thing to figure out how it works. Rather than, you know, the client can lay out, like, this is how it works, this is the architecture, and then we can just put our fingers and say, all right, you know, based on this, probably the easiest breakpoints would be these, this, and this, and this. And then we would arrange testing those things to make sure that there are no vulnerabilities in those, let's say, breakpoints. Right, and that's kind of one of the main things we do. And we've also been working a lot with security by design, which is where we accompany companies and products to make sure that, you know, you don't get security bolted on at the last minute, which ends up being no good security, but rather that you make we support you to make conscious decision about the security in the development of the project, so at the end you have something that's actually robust, right? That will hold its weight and will help you to do all that certification.
And just so people understand that, that's both secure network, secure software coding, secure application development, all of that. And that
exactly.
And there's all different kinds of security. So that security also plays in with like Chris's security of the end-to-end encryption of the system, or
that would be exactly one of these type of decisions, right? When someone's saying, okay, we need to access these devices, then we can come and say, all right, you want to do end-to-end encryption to make sure that this is secure and that you don't have a backdoor there. And then we could help the client evaluate the options and, for example, go ahead and dig into our ecosystems, like, oh, we've worked with Chris before and we know that this solution is sound. This could be an option, right? Either this or something similar to this, to that way you have secure access there. Or, you know, if someone is dealing with some binaries and, you know, they want to make sure that these binaries are secure, we could go ahead and pull out to reach out to Binary.io and Andre and say, hey, we got this firmware, right? The client has this firmware. Can you please go ahead and analyze it? So we kind of put together lots of the elements that we've seen in the ecosystem, right? And try to help clients have a secure solution at the end of the day.
And then and just to give Roger a lead there too. And if you need to be able to ensure that that software can be updated remotely and over time, and with Robert's comments, where it is at any given time, we're now starting to paint the story of how all of these pieces are coming together in our conversation today.
All of these pieces are really important because the security is not just, you know, someone that tests something and bolts it on. You have to design it into the system for it to be effective, right? And you have to take a look at it holistically. So basically taking all the different elements we have in this ecosystem today, and combining them in the smart way and figure out the best way they can go together is basically where we help you help the customer say, all right, help you take these difficult decisions, because, you know, most of the customers don't know the jargon and engineering and, you know, what does this cipher suite mean? It's like, you know, we can help you pick the right one so you end up having the right thing, and it can evolve over time.
Fantastic.
Yeah. All right. And then one of the other things that we've been doing is, because we know that lots of people lack this knowledge, we're doing a bit of a training. So we have some hands-on training that allow people to, you know, get their hands dirty and actually do the security testing and figuring out what an attacker is actually going to do to his product, so they can design it in a better way. And then after a couple of years of writing the same reports, we started to develop a bunkai system where we're going to support automatic and semi-automatic tests to provide evidence for these certification schemes that are coming up. So Android is already naming the ETSI certification scheme, and there are a couple of others. You know, there's these in California. There's security laws. There's a Cybersecurity Act that's been being kicked off and will be coming into play. So the idea is that you have a single pane of glass where you can collect that information and you have evidence that allows you to show compliance, right? And to actually test things that are secure, right? And for example, Sariot is a big piece for us in this, because they're providing us the SIM cards and the traffic. So you can actually test and see what is this device doing? Is it phoning home? What information is it sending home, right? So you can actually see, am I being managing the user's data in a privacy conscious way, right? And yeah, so that's kind of what we're trying to build into Bunkai to allow, to kick off all these things. And we're actually pretty excited about, there's a whole bunch of legislation that's coming along, right? For example, I think I already named it Cybersecurity Act, and also these things are based on ETSI standard, and all of these different things, which are somehow going to push people, or finally push organizations into the position that they want to do the security testing, right? Because let's be honest, nobody pays money for security if they don't need it, or if they don't think they need it. And it's kind of like the auto industry, right? Seatbelts were around since the 40s, and they started being obligatory a lot later than that. So this regulation is kind of going to help or push people in the right direction to make sure they have secure products by default, and we want to be there to be able to support them.
Well, and moreover, and maybe you can talk to us a little bit too about the trust mark, the U.S. Cybersecurity trust mark that's being put in place, much like the electrical CE mark on the back of devices. I suspect we're going to start seeing these types of cyber trust marks too, that would potentially be supported by players like yourself, that would help a consumer like myself buying this device. And so that mark would then be certifying to me when I see that mark on the device. That will tell me it's been tested and like my data is not being siphoned off of the device.
Exactly. And actually, this part of the efforts in Europe is that you're going to include cybersecurity testing in that CE mark that we already have, right? So when you buy a device, you're going to need that mark to be able to sell it, which is going to basically give the consumer a lot more security, because if you're allowed to sell it because it has that CE mark, it means that it is including a baseline of security in it. So it's definitely not that bad of a product.
Fantastic. Well, gentlemen, we could go on forever. And Pablo, did you have any final last remarks, or?
I think we're actually going to go into them, because I think what's going to round things off are these, this regulation, this legislation. And I think that's actually one of the next topics you're going to jump into.
Yeah, so. And so let's kind of talk about this. So this idea of IoT has been evolving rapidly over the last few decades, and it's now, as I said earlier, we are all now becoming phygital connected beings, and we really are no longer living a life without being connected in some way, shape, or form. And with recognition of that, and not just we as individuals, but as was said earlier, as from Chris, our companies, our entities, as well as our things, everything is becoming connected. And with that in mind, governments and industry players around the world are recognizing this and saying, well, wait a minute, we've got to do something about this. So we're seeing everything from governmental legislation being put in place, from independent standards bodies like ETSI, establish standards that we can all follow to make sure that we're following these protocols and these methodologies right. ETSI has two standards, the 303 and 645 standard, that's specifically catering to IoT. And we also then have industry, the best practices and leadership coming from organizations like Zarya and all of you here that are helping set those policies and those best practices. So we're in this kind of regulatory scheme, we're really seeing this continuum. Everything from regulatory activities to corporate contracts and policies, and then the best practices in between. So that's coming today quite a bit, as is, for instance, the U.S. cybersecurity trust mark that we just talked about. These are the ETSI standards. If anybody wants to go refer those and to look at them. And then, as has been eminently evident throughout our entire conversation today, this is like kids don't try this at home. I mean, we need a team to put this entire IoT ecosystem together. And I think we've really had a great vision and a collaborative view that allows us to bring these diverse sets of skills together to make an end-to-end secure IoT experience for all aspects of our lives today. And we've just touched on this quite a bit. And in addition to that, we need to know what's in these devices. I mean, we're no longer able to, this is like a trust but verify. And that verification element is absolutely critical, not just at the software devices, but also the verifying in terms of certification and testing. So the kind of call to action for anybody listening to today's webinar is, if you want to understand the DNA of IoT and this broader ecosystem, I highly encourage you to reach out to Jimmy and his team and to understand all of these ecosystem players. And wherever you may be within that ecosystem, Jimmy and our players here today that you've been speaking with, you can connect with them and help them understand, who do I need to be working with? How do I actually deploy this? Where do I need to go? And the great thing about it is you don't necessarily need to understand all of the acronyms and all of the buzzwords and all of the protocols and all of the capabilities yourself, because that's what the team is there to do for you. And so with that in mind, I just, everyone, I'd like to thank you very much for joining the time today. We have run a little over, so I don't think we have time for Q&A. But if you do have questions, and let's just see if we have one that's come up. If you do have questions, actually, we do have one. Thinking out loud only doesn't cost, okay, here's one from Livia, and then we'll close it out. Doesn't it cost less to invest in security rather than playing the destruction of ransomware attack or corporation espionage? I understand the need and urgency to deliver product and to be able to reach and to defend the trademark, the user data. So,
she's absolutely right.
Yeah. So can you talk about that a little bit, Jimmy?
Well, Livia's she's hit the nail on the head. She's entirely right. And that's the whole point of the ecosystem. We want to be able to put safe, secure solutions out there, not only for the customers, but for the enterprise owners as well, because it's your reputation. The ransomware will cost you money, but your reputation will cost you more. And that's why we work with the guys here, and they can bring not only that security, but the innovation as well. If technology was no object, what would your connectivity do for you? Ask us that question and we'll do the heavy lifting for you, Livia.
Yeah, and on that note, and I want to, before we move on, let's not forget that every one of these devices are going to be bestowed their own identity. And as we move into Europe, we should not just be looking about the regulatory side of IoT, but I also highly encourage all of you to be paying attention to what's happening on the side of just generalized identity, like the emerging EIDAS 2.0 regulations in Europe, the WC3 verified credential standards, the effort that, and the technologies that @Sign is putting together to enable secure elements of that data, because one of the core elements of all of this is we have rights to our data. So in addition to being essentially having security by design, privacy by design, we're also going to have regulation by design, compliance by design, and then ultimately the aggregate of all of that becomes trust by design. And trust will become the number one differentiator for players going forward in the market, in my opinion. So Olivia, thank you very much for that question. Everyone, this was just absolutely fantastic. I enjoyed it thoroughly. And Jimmy, since this is brought by you, do you have any final remarks for us before we shut it down?
No, I just want to thank everybody for joining the ecosystem, and the partners we have here is always growing, but the 6 guys on here are just, they impress me every time I hear them.
Fantastic. Well, everybody, let's just shut off the screen size so everyone can say hi, and we'll catch you next time. Thank you very much.
Michael.
Thank you.
All right, everybody. Bye-bye. That was fun.